Yep.
Okay, next one. Yeah, it's quite similar to the other one.
Okay, what one's this?
So this is the second paper we will see. Actually, we see most of it last week. So the first question, what do you think is the first question?
So volume. Okay. I can't remember the volume equation for volume.
What's the SAE for the length of something?
Mm-hmm.
If you measure something, the SIE units from a distance, what do you use? If you measure a distance,
You can use.
so you measure from here to here.
Mm-hmm.
What do you use? What units? Say is 5 what?
About 5 meters.
5 meters. So if you measure from here to here, you have another 2. It's still the same, right?
Yeah, 2 meters squared.
So yeah, and if you calculate the third distance, then is so like a volume. So it's then 1 meter. So if you use meter in all of them, then what is the obvious answer?
This meters squared.
No, 1, 2.
Oh, meters. That's 3 cubed.
Cubed.
Yeah, cubed. Okay.
Mm-hmm. So how do you show that the SU base units for pressure?
Pressure is force over mass, I think. Yeah, yeah.
Pressure is equal to?
Force over mass.
No. So when you, for example, put a piston of a car, so the piston put the force. And what you need to know is this. Not this volume, just the area of the piston, so the circular. Mm-hmm. So what is this force?
Okay.
Over area. Mm-hmm.
Okay.
Over the area of this surface of the piston. Mm-hmm. So what's the units of?
So F is kg.
No, well,
kg m squared s to the minus.
Force is measured in newtons.
Okay.
But the force, what's the equation of the force?
So F equals ma.
Mass times acceleration. And the area?
Area.
Well, what's the area? It's just side by side or the area of the circle.
Yeah.
But the area remains the same. But the units here, for example, this remains. So the units of the mass
times acceleration.
The units of the mass is
so
kilograms. The acceleration?
ms. No, m.
Mm-hmm.
Yeah.
Meters over
second squared.
And the area? The surface.
This is meters squared.
Meters squared, yeah. Mm-hmm. So this remains equal. This eliminate with this one. Mm-hmm. And so end up like kilograms, meters minus 1, seconds minus 1. Sorry, minus 2. Because nothing happened to this.
I see. So volume. Terminations, let's see. Okay, I'm not sure. I'm not good with this, this sort of stuff. When the peak, the pressure difference between the ends of the pipe, this is still just the units. So first, what they are asking you, the units of which? Of C. So you have to leave C alone. Mm-hmm. So you pass C to the other side, and the volume and the time. What is T? Yeah, and the time towards the other side. So you will have P
times the pressure, the square, times the time, over 8 times L volume. The only thing you have to do is to substitute for the units. So R remains the same, so it doesn't have units. The pressure is an so we can say the same. Yeah, I think it's best kilograms according to what we see in meters. Second minus 2.
Okay.
The R is a distance, right? The radius, which is still in meters, times 4, and times in seconds. 8 is a number, L is a distance, again in meters, and B is a volume.
And so 3.
So if you combine this, it's n times n to the 4.
Yeah.
So this one with this one eliminates. This one with this one eliminates. So either
So be kg ms
n minus
yeah,
1
minus 1 to h. Yeah.
x minus 1, and that's the units of thing. Second, how did you solve this one?
What's the question? There's no question yet. Labeled vector triangle to represent the forces acting. Please draw the forces. Right. On the climber. Okay, so weights acting. So it's on him, you just draw the forces.
So the weight is here. What other forces should I put in the diagram?
So there'll be tension from the rope.
The tension? We have this tension.
Okay.
So from here, actually, or from whatever point, you can actually put the tension. And you from here, you have the normal to the plane. There are at least the 3 forces that are acting and keeping everything in balance. So the thing is, you have one in Y and the other one in the x-axis.
Yeah. Okay.
This tension will have 2 components, one in Y
and x.
And one in x. The thing is, will be pointed. So this is t dy and
Tx.
dx.
Okay.
So this is opposing the r, and this dy is opposing the y.
So tension. So the tension, so we tension's there, so we T cos 18 is W, is the downwards force, the upwards force equals downwards force. So yeah,
W is
T cos 18.
equals 18, yeah. And do they give you?
By the way, it's 520,
so it should be
T is 520 over T cos 18. Or is it?
520.
No, yeah, it's over
520 newtons over
T cos 18. No,
Cos
yeah, cos 18.
18. Yeah. And it gives you, should give you a result. Let me. Because I don't think I must have write down, but nothing different.
No, I can't change it. I can't work it out.
Let's put the value. Almost 5 minutes. 520 over cosine, right? Yeah, 780. This. So
So
I think it's
787.
Okay.
Point five.
Reaction force R. That's the X components. So it'd be sine 8t sine 18. Because it's opposite is not Y. So causes. Yeah, so it's
Sine,
T
yeah.
sine 18.
Yeah, this is. So this is T1. So T.
No, TX, yeah, so T sine 18.
T sine of the angle will be R.
Yeah.
We already have the value of this one, so R will be 787.5 sine of 18 degrees, right? Times 591. 591 newtons.
Okay.
Yeah. The clamber moves out. So what do you think is the answer here?
So as he climbs up, that angle will increase. So the vertical thing at what T is smaller, therefore or T is larger overall. As the weight, or the tension is weight over cos theta. So W equals T equals W over cos theta. So therefore T increases as the angle increases.
Yep. Increases as the angle increases. Okay. What is work done?
Work done is the distance over the displacement. I think displacement.
Distance is displacement, yeah?
Distance over displacement.
No, it's the same. It's practically the same thing.
The distance moved. So when the force moves in a direction.
So you are
of
here.
Force.
You have carrying a box, and you move this box towards here. So you have done one work. What did you do?
You moved it.
You move it, but so
You transport it from one place to
so what this arrow means? You put. So not necessarily that you carry, you can actually push it and you still
That's
do
the
that.
displacement.
Yeah, the
direction
displacement.
displacement.
You make a displacement. But what else you do? So you need to apply
Force.
a force. So it's a force times
Displacement.
That's work done.
Oh, okay.
Okay, B. How do you solve B?
So calculate the weight. That gives you the mass. The W is
The W
mg
is
theta. No, yeah, mass times gravity.
Gravity is 9.1.
So 9.81 times 850 times sine 7.5.
That's what. So the sine, which is this one or this one?
Sine, so
Is the f of y or the f of x?
it's the weight, it'll be Fy, won't it? So it's the weight.
So, but actually it's the opposite thing, right? Oh, yeah, it's okay. No. So you have the weight.
So sine 7.5.
It's 850 kilograms. That's 9.81 meters per second.
Times sine 75.
Sine of 7.5. No, this one. Okay, because we need the result for the other one.
I put 1 6 here. Yes. So the f of y is equal to 721 newtons, of course. Shall we calculate the next one? See.
So the traveling at constant speed of 25, if I separate the force, resisting is 4,600, so that the deceleration. So it'd be 4,600. It would be take away the weight, which would be the one from the answer of the last question. And then you would.
Second?
So you'd get the force, which is 4,600, and you would take minus the component of weight from the last question.
But the other one is bigger. Or maybe
You sure? Try it.
this is 7,821.
Is it what the
The question
Wait.
for resisting the motion of the car. But this is the component in y.
what for the?
For the
I think you'd it's 850, not 8,000.
No, it's a. Let me check. Yeah, I think so. Let me check. 850 and
9.81. And times sine 7.5.
it's yeah. There was another mistake. It was in radians instead of degrees.
Oh, okay.
0.49 point.
Yeah, that's a bit more
Actually.
suitable number.
Yeah, 1050.
So it'd be minus 1050,
Mhm.
which is 3,550, I think, or 3,510.
3550
3,550.
newtons.
So that'd be, you would then divide it by the mass, which is 850, and that should be 4.1.
Mm-hmm. 4.17.
Yeah, so just checking.
This is take square. Interval second. Yep.
Yeah, so 4.1. So travel the distance the car travels and it breaks up the road. So you need to find the velocity to find the displacement.
Which equation would you use here?
Maybe v squared. Oh, I need to restart the time.
Okay. Yeah, you can have. You want to take a break or?
I'm fine. That's why it's probably better on my phone. 'Cause you should turn the sound on the back.
That's okay.
So anyway, just make sure.
So no worries.
So v squared equals u squared plus 2as
Sorry, this one
equals u squared plus 2as.
plus 2as.
So v squared is 0.
Yeah.
So is v squared. I think u squared.
Yeah, well, either it's b or u. It's going to be the same. So you will have.
A is.
Sorry, no. So.
No, I think it's v dash 0.
Yeah.
Yeah, and then u is. You're given u. You're given u and a.
The 25.
So u is 25 and a is minus 4.1.
5. Just a second. And this is the distance, right?
Yeah.
So we have t equals to 0, so we just have to pass minus u squared. With 2as, right? And what's the result?
A is minus 4.1, so
Second?
sorry. Yeah, so it's minus 4.1, so it's the opposite direction, so it's minus.
Yeah, that doesn't really matter. Practically, this is telling you.
Oh, okay. So yeah, it's 4.1 then.
2 times 4.1. 76. 76 meters.
Yeah, I think that's it. So kinetic energy, that's
How do you calculate the kinetic energy?
half mv squared.
mv squared.
So
So it's half 850.
mv is 25
25 meters second.
squared. Squared.
Oh, sorry, yeah. So 0.5 times 50. That's shallow. So it's 26, 56, 25. Yeah, because it's in joules. Yeah. So in other words, it could be 265 kilojoules. It's much better than this. So how do you calculate the work done?
So work done is mgh.
To resist the force of 460?
Oh,
So it's, what is the displacement? 76 meters, right?
yeah. So it's 4,600 times 76.
Yeah. For 600 newtons, then 76 meters. 26, right? I see. 600 joules. Then the numbers looks bigger because in joules. Joules is quite small unit.
Okay. So why are they not equal? It was the difference of the two is the loss in potential energy.
Yeah.
Yeah. Oh, okay.
Yeah, because you have.
I'm surprised that was right.
Yeah, this work done is mainly just
Yeah.
the total energy you're applying. It's all that energy done. This is just the kinetic energy given by the velocity of the car. But you have also this component, which you never use it. If you add it up, the potential energy. Yeah, maybe there is no.
Find a torque. I don't know how to find torque.
But it's the torque of a couple.
Yeah, I have no idea what it is. Really.
So we said, for example, to start to talk
I know
about.
what it is, but I just don't know how to define it.
So it's just a balance of forces, right? For example, here you have one force, another force. So this force, when you have this pivot point, is moving up, and the other moving down. If you actually moving, if this is the pivot point, so if both of them are opposite, this is moving down like a seesaw, and this is also moving down, the system will be in equilibrium. But when it's not in equilibrium, what's happening is just one is moving towards this one.
Yeah. Loop.
First is a non-equilibrium system. It's non-equilibrium.
Yeah.
System of forces. Acting in that pivot point. The same. direction.
Yeah.
And this is actually what they're asking you. This is a couple. One is going down, the other one up if you have the open. But you have here another thing, I think.
So
How do you
calculate the torque on the rod? Wouldn't this be 8 times 1.5? Because that's the distance across it, and yeah, it's 8 other side, so yeah, maybe 8 times 1.5, I think.
8 newtons times
1.5 meters.
1.5 meters equal to?
I think it's 4 plus 8 is 12. So 12.
What is 12? Where did the 12 come from?
Newton meters. Because, yeah, you should add the values. So 12 Newton meters. Or 12 Nm.
Yeah, but where did you obtain this 12?
Because it's 8 times 1.5.
Well, yeah, 12 newtons meter, yeah. But what is this? So this is the
So it's a thing of the rods times the displacement across it.
yeah, but it's
I should explain it.
so is the rod in equilibrium?
No.
So I don't think this is the answer.
No?
Good. Not sure. You're missing something.
Oh, well, where is it? So I'm not very good with this sort of stuff, so I'm not sure what I'm missing out.
No, sorry, you're right. No, it's fine.
I'm right?
Yeah, you're fine. Yeah, I think so.
So it's not in equilibrium as the rods are rotating, so there's no resultant force, so the torque's is a result. So it's resultant torque, I think it's called. So it's a resultant torque.
It's a result in the torque.
So it's
it's not equilibrium.
equilibrium.
So there is, you don't have that setup. Yeah. Okay. Question 5.
So show the relationship. Oh, that's easy. That's I1 equals I2 plus I3.
So 7,
I1 equals I2 plus I3.
I1.
That's easy.
Equal
I2 plus I3.
Yeah. Okay. That's easy. Next one.
Okay, I1.
Oh, you're ready. Come on.
Where's the I equals VR over R? I'm pretty sure. Is that the equation? Or is it a different one?
Yeah. So you have the values of the current.
So V will be.
How do you calculate that?
Yeah, I'm not sure. How to find it? I haven't shown the equation. I'm not sure how to get the values for this. Circuits are
So
weird.
you need the value of this and the value of this in order to obtain the value.
Okay.
So what is the value of the voltage? How's the voltage in a parallel system?
There's 12 volts.
Yeah. So let me see. So the total voltage is 12 volts.
So
The resistance of the wire, resistance 1 is equal to 10 ohms.
so I2 is 12 volts over
The resistance
10
2.
resistance. So 12 over 10, won't it?
But this is I2. Only I2. if you calculate from over here. So the resistance 2 volt per ohms and the resistance 3 equal another 2 ohms. So you see the difference in the potential. The total difference potential is 12 volts.
Yeah.
So how do you calculate then
So for I equals U, I need to figure out R. So R would be
how do you calculate, for example, the total resistance of the system?
total resistance U. Oh, I should know this.
So you have
Mine's gone blank.
in series. What do you do in series?
In series.
For example, these two are in series. What do you do?
So you add
When the resistance are in series, for example, resistance 2 and resistance 3, I call it.
Okay.
2 and 3. And the Y is the resistance 1. So when they're in series, you just add them up. When they're in parallel, what do you do?
Do you take them away? No, why'd you take them away?
No.
No.
You add them, but in a different way.
Yeah.
They're reciprocal.
Oh, the reciprocal.
Yeah.
Oh.
So
Wow. Yeah.
R1
I'm
plus
so sorry.
R1.
I can't focus. Yeah, just one over.
So that's the total resistance you have. So it's 10 control values. One over 10, but for one. Yes. One over 6, right? So the total resistance is 0.27. Well, the inverse. So minus 1. So total resistance should be another 0.26. 3.7. 3.7 ohms in total. The total resistance.
Okay.
So if you
That's
know the resistance, the total resistance.
That's total resistance. Is 3 point.
So and you have the total resistance.
And you have the volts, which is 12. So it's 12 divided by 3.7.
Sorry, 12 divided by
3.7.
3.7. Yeah. And the current. Yeah, 1.2. So the answer is 1.27. It's very low.
Yeah.
Oh, sorry. I need to shake it. Sorry, it's 12 over. You say 3.7, right? 3.24. This is 3.24.
Okay.
How do you calculate that?
So power is VI.
Is so?
P equals VI.
So the power is equal to?
Oh, VI. No.
Are you sure?
I think so.
You don't have much options, but are you sure you are not missing something?
I'm not sure. Oh, I'm not sure why I'm so tired today.
Missed the question. I'm sure I'm missing something. Okay. That's fine. Sure. It's with the resistance. Yeah. PVI. So how do you calculate then the voltage here? So you need, if power is PVI, so you have the power in 1 over the power in 2.
Okay.
So you have the current theory with the name 2 and 3. So 2 and 3, and you call it the same way. So how do you calculate the voltage? So what's the voltage in a parallel circuit? These are in
And
parallel.
this one is 12.
The total voltage is 12.
Yeah.
But in a parallel system, how do
So
you?
it'll be 6. Yes, we'll go for 2 halves.
Really?
No.
So in a when you have these nodes, the current divides, but what happens with the potential?
It'll stay the same then.
It's the same.
Okay.
So what actually here what happens is if it's the same,
It's, yeah.
it depends on that. Yeah. The value of y.
So I2 over I3, which is
Um,
equals to I1.
Yeah. How do you calculate then I2 and I3?
So, um, so you could use, it didn't really work out I2 and I3.
So you already know that. So if the total voltage is equal here, so we call it V2 and V3. All of them are equal to the same voltage, 12 volts. You also have the resistance ones, and the resistance 2 and the resistance 3. So how do you calculate them? I1 and I2. Sorry, I2 and
So
I2.
that you'll divide it by each one by, or 12 by each one. So resistance. It's like 12 over 4 and 12 over 2.
12 over, and the I1 is 10 ohms, right? So it's 1.2.
And then
And I3 is 12 over 6.
maybe over 2.
So 2. If you add them up, it's 3.2, which is what we have here.
Yeah.
3.224 is practically the same.
So then now we've got I,
So and then you divide it
which is
here,
3.2.
1.2 over 2.2, right?
Yeah.
That's 0.6.
Okay.
So the answer here is 0.6. Okay.
Between the
The
point
potential
C and
difference over C and D.
C and D. Oh, that's a hard question.
So you have here and here. You have a potential difference. How do you calculate? So if you put the voltmeter here and here, they equal to 12. Probably the same here.
Yeah.
But not if you calculate, if you put it on both sides.
I'll have to answer this.
So we said that, for example, from in this line, only on the whole line, from here to here, the same from here to here. The voltage is the same in everything, right?
Yeah.
So it's 12 volts, but here it's in the whole wire. This is a special wire, where the resistance is not the same as the rest of it. And from here to here as well is 12 volts. But from here to here, it's different.
Yeah.
How do you calculate first? Actually, we can say from A to D.
Online.
It's a potential divider.
Yeah.
So the voltage will be equal to the total voltage over a relationship,
Okay.
which would be the resistance, the total resistance over the resistance what you're calculating. Total 12 over what is the total resistance? So the total resistance 6 over, so the total resistance of this, just this one.
Yeah. That's it.
So it's 4 over 6. 4 over 6.
Okay. It's like 0.6 maybe.
Give me to let me see if I can get my notes in that way. I don't need to go to the calculator. Wait a second. Do you need more less? Do you need less?
I think so.
You want the rest?
I don't need a. I don't think.
If you want to take rest, you can.
No, I think.
Okay, no. It's ready.
No, I just want to get this paper done today, see if we can get through all of it. So we can get through the last one, so I want to get through all of this one.
Okay. Let me see. You need to.
Because this paper's not that easy.
Yeah, the thing is, if I check the workout, I don't have to check the computer, the calculator every time.
Yeah, that's fair enough.
I'm fine with that. Yes, what is it? Okay. The question is 5, right?
Yeah, question 5B.
So it's 4.8. If you do the same thing with, but with the cable. So here you have 4 times 2. So it's exactly the same, but instead of using the resistance, you will use the distance.
Okay.
So the total distance is 1 meter, but the distance from here to here is just 40 centimeters.
Okay.
So it's going to be exactly the same. So it's going to be 12, the distance 1 over the total distance. And it's going to be again 12 times 0.4, yeah. So this is 4.8 and this is 8.0. And the only thing you have to do in these cases is to take them away. Yeah.
So it's
So 8 minus 4.8.
So it's
And then
3.2.
3.2. Yeah.
Okay.
So that's the only thing you have to do between these 2 points.
Oh,
so,
cool.
So this is working like a potential divider, and this is working more like a thermostat, where you can adjust the resistance just by moving the point towards the cable.
Okay.
State Hooke's law.
So the extension of an object is proportional to the force. So extension is proportional to force.
What do you need here? Constant.
Yeah. Okay.
So this is what you said will work, but in equation that's how. There's a mistake in the notes that says proportional. This is not proportional.
Yeah.
This is inversely proportional.
Yeah, that's proportional. Yeah.
Proportion would be more equals to the equal. There is not actually a single root.
Okay.
It would be an equal plus a constant plus the force. Okay. The variation in the extension F with the force for a spring is shown.
Elastic limit. Isn't that when it doesn't, like, after it's extended so much, doesn't return to its original shape?
So
Size.
the elastic limit, yeah, describe the elastic limit.
So when the,
Say again?
it doesn't return to its original shape.
So the point of the graph is the elastic limit of the spring. So what's the elastic limit?
The elastic limit is the point beyond the extension where the string does not return to its original shape once the load is removed.
Yeah. Well, next one. So it's not actually just a spring, so any material
constant. Isn't that the gradient of the graph you just need to use?
Yeah.
Okay. Is a gradient.
So how do you calculate the gradient? This is where
you change in y, to change in x. Or what? Yeah.
So, but how do you do that?
You can take any 2 points, can't you?
Any 2 points. Take out. So it's 7.2 over 9. And this one, Newton meter.
Okay.
Yeah. Yeah, but because it's time. Sorry, 9 times minus 2.
So the work done is the gradient under the graph this time.
But it has an equation. So if it's the
something.
So it's easy. For example, if you have,
I think it's half f.
So if this
half of x. That's it, half of x.
Yeah, it's a square, and it's only half of it, and this line is divided the square. It's just half. So it's the work is the half of x. And that should be around 0.256 joules. Just using the same. Okay. 7. Very close to the end.
I don't like this. So, determine the amplitude.
These are
It's not at 8 yet. Yeah, so maybe around 7.5, 7.6-ish.
So it's moving in terms of force, so 7.6.
Okay. Oh yeah, of course.
Yeah. So the second one?
So for the phase difference between P and Q. P and Q, that's half. So that's 180. So it's pi 2 over pi, 180 over pi. This is half.
Right. 180 over pi. Yeah.
I'm glad I remember that.
And the third one, you're quite close.
The speed. So the velocity is F lambda.
F times lambda. Yeah.
So it is.
C is 15 times 0.8, and that's 12 meters second.
Okay.
So we say that there is always a relation between the frequency and the lambda. So if you calculate the velocity of the speed of light, so everything that changes with the velocity of the speed of light is always the same.
Okay.
You can change the frequency of the lambda,
Yeah.
but the speed of light is the same.
Phase difference. There isn't any. 0.
This
There's
is
no difference. Same point.
yeah. It's 0.
Yeah, there's nothing.
The next one.
So that's the same question.
Yeah. Sure.
The I don't like these. I know antinode, but I don't know. No, antinode's like the maximum displacement. No, maximum amplitude is for antinode, but I don't know what node is.
So when you have a stationary wave, how do you create a stationary wave?
What do you mean? What way?
So a displaced wave. So this is a transverse progressive. That means that you move and you have help me with the word. You have an amplitude.
Yeah, amplitude.
And so you have valleys, so peaks and troughs, right? So a crest and a trough. But in an antinode, so when you move this wave, for example, in a rope, and you do this, so hit the wall and then it comes back.
Yeah.
So what's happened when it comes back with the same wave. And it seems that it doesn't move. So this is the, how do you call it?
Antinode.
Antinode.
And then the node is where they join in the middle.
Exactly. This is the node.
Okay.
So this would be equivalent to the amplitude, and this is just equal to the node one.
Okay. So the number antinode is shown in 7.2. Wait, what's figure 7.2?
This one.
Okay, so how many antinodes?
So
3. Yes, 3. So it's 1, 2, 3.
Yeah.
Yeah, 3 antinodes.
Yeah, this one.
Oh, that isn't really a wave. It's just a straight line. They're trying to trick you.
The period of vibration of wave is.
Yeah, they're trying to trick you. It's just a straight line, a horizontal line for the for the central part of the wave. Yeah, it's just flat line.
Okay. So number 8. So they describe the Doppler effect.
Isn't that when the frequency is different to an emitted frequency, when the motion between the observer and its source is something, but
So the
it's just the definition is a little hard. It's so long for this.
so remember just the car. So when the car is static,
There's no movement.
there's no movement.
Be the same.
So the frequency is the same from the car from the observer. But it is when the frequency is different when the emisser is in movement either towards or away from the receptor.
Decrease.
So the frequency go up or go down according if it's coming towards you or away. So how do you calculate the P-power?
So F equals.
So the speed is
Oh god. I'm not sure. I don't know the equation.
yeah. The equation
I've
actually
the equation of flow, but I don't know it.
is not even in the notes actually.
No, it's weird.
It's equal to F. So if it's SB over meters.
That's weird. That's a weird equation.
That's just a difference.
Yeah.
So it's a relationship between the velocities and the frequency. So one is the frequency of the observer. So calculated of the frequency here, the frequency of the emission. So this is just the velocity. So the velocity of the medium. In this case is the air.
Okay.
So when you speak, so the velocity of the medium makes you so it's the same. So the velocity, that's how it travels. When it's the vacuum, for example, that's the reason how you calculate the speed of light. So it could be, for example, the speed of light.
Yeah.
But here you are adding or subtracting according to what you do. So it says when it approach. So when it approach, the frequency has to go up. So what you do is to rest. So here would be the frequency of the emission times the velocity of the medium. So at the velocity of the medium, you have to rest the velocity of the stream. So this number is going to be smaller, and in error, it's going to be larger. And this gives you around 10,010 hertz. So the frequency, original frequency is 880. When you calculate, so it would be. So the total frequency is 880 times 340 or 340 minus 44, right? 44.
It won't receive be the same, but it's plus 44.
Plus 44.
Okay.
Because this number becomes larger and then the frequency becomes smaller.
Yeah.
And it's more convenient.
Okay.
Yeah. But it's just the same. It's just a relation between the frequencies.
Yeah, that makes sense. Oh, class of between. It's easy as hadron. I like this sort of stuff. It's quite easy.
Yeah, most popular.
This last one. So the proton inside nucleus decays. Write the equation. So it's 1 P. So one proton, one. Yeah.
Proton is
So it's 1 1.
1
So it's an arrow. So 1 O N. Plus 0. It's a beta particle, so it's 0 1 B beta.
Beta what? Minus or beta?
No, plus. It's plus. And it's plus
Okay.
V.
Yeah.
E.
Yeah.
Cool.
Yes. So B is the neutrino. So you apart from the beta particle, you always emit a neutrino.
Yeah. A proton. So a neutron is down, down, up. A proton is up, up, down.
Up, down. And the decay?
The decay of a proton, so an up changes to a down.
And that's it.
Oh, cool. We got through it with one to spare.
It's up to you. I don't know. I don't think we have.
That was, I like that. I enjoyed that. That helped a lot.
Because I don't know. I mean, I don't have anything else prepared.
Yeah, I wasn't expecting to do anything else, so.
So let's have stone.
Yeah. Tom's left already, so Andrew said if we've got anything else planned, we could just finish it.
Okay.
I'll stop recording.